Recall that the given three sides, a triangle can be formed only if the sum of the smaller two sides is greater than the third. If you guys remember the triangle inequality theorem, A plus B, the two smaller sides, has to be larger than C, or you can't make a triangle. Why is this important? Well, I'm going to be asking you in a minute to use the Pythagorean theorem, or actually its converse, to determine if a triangle is a right triangle, an obtuse, or an acute triangle. But you can't designate whether it's right, acute, or obtuse unless you know it's a triangle. So let's check these out. Let's review first. What are my two little sides here, 4 and 5? The question is, can these be the lengths of a triangle? We're not looking at Pythagorean triples right now. We are just looking at the plain old triangle inequality. 4 plus 5 we are going to compare to 6. And 4 plus 5 is in fact greater than 6. 9 is greater than 6, so yes, that can make a triangle. Let's try this one. Is 4 plus 5 greater than 9? And the answer is no, it's equal, so this cannot form a triangle. And let's look at the last one. Is 4 plus 5 greater than 10? And the answer is no, it is less than 10, so this cannot form a triangle. So only A can form a triangle. So let's use this. We can call triangles right, acute, or obtuse. How does the Pythagorean theorem and how do Pythagorean triples fall in, work into this? How do they connect? Well, we can use what's called the converse of the Pythagorean theorem to determine what kind of triangle we have. First of all, you have to determine, is it a triangle, by adding the two smaller sides and making sure it's bigger than the larger one. And then we can use the converse. If you guys remember what a converse is taking the hypothesis and conclusion and switching it. So what does the Pythagorean theorem say? I'm going to go ahead and write it out for you. The Pythagorean theorem, if a squared plus b squared equals c squared. Whoops, sorry, I'm going the wrong way here. The Pythagorean theorem says if you have a right triangle, if a triangle is a right triangle, then a squared plus b squared equals c squared. So that's the original. So what would the converse say? Well, I'm going to come up here and I'm going to write the converse. The converse then says if a squared plus b squared equals c squared, then what can I say? It's a right triangle. So what I'm going to do is I'm going to test a squared plus b squared and compare it to c squared to see if it's a right triangle or not. So a right triangle can be formed when c squared is equal to a squared plus b squared. Okay, we've established that. That is the Pythagorean theorem. C squared equaling a squared plus b squared. Okay, you can see it here. You can see it here. Remember, it doesn't matter what order you write it in. You can say c squared equals a squared plus b squared, or you can say a squared plus b squared equals c squared. What if a squared plus b squared doesn't equal c squared? When c squared is actually smaller than a squared plus b squared, we have an acute triangle. So you can actually use the idea of the Pythagorean theorem and the squares to determine what kind of triangle you have. And if c squared is actually larger than a squared plus b squared, it is an obtuse triangle. So what we're doing, this is called the converse of the Pythagorean theorem. And it's called the converse for the reason that I just showed you. Because instead of us saying we know it's right, so a squared plus b squared equals c squared, we're going to have to determine first, is a squared plus b squared equal to c squared? Then it's a right triangle. So let's come down here and apply these properties here and see if we can figure this out. Let me delete this one here. Actually, my eraser doesn't want to work, so hey, whatever. So let's check this out. Let's look at the first one, 5, 12, and 4. First of all, can it be a triangle? Yes or no? And if it's a triangle, what kind is it? Well, let's check it out first. What are my two small sides, 5 and 4? Is 5 plus 4 greater than 12? No, it is less than 12, so it is not a triangle. Therefore, we can't classify it. Excuse me. I can't call something a certain type of triangle if it's not a triangle. You can't call a motorcycle an 18-wheeler. It's not an 18-wheeler. You can't say, I have an 18-wheeler. What kind of bicycle is this? If it's not a triangle, you can't call it a triangle. So let's check it out here. 6, 7, and 8. My two small sides are 6 and 7. Is 6 plus 7 greater than 8? And the answer is yes. So I can now classify this triangle. So let's figure out what kind of triangle it is. Go back up to the top right here. Here are your classification schemes. Okay, I'm sorry that green is in the middle of the screen up there. But there's your classifications right there. So I'm going to compare c squared to a squared plus b squared. So c is 8, so I'm going to compare 8 squared to 6 squared plus 7 squared. If I work this out, 8 squared is 64, 36 plus 49. And I always put a little circle here because I don't know what fits in there, greater than, less than. I haven't done it yet, so 64 on this side, and if I add 36 and 49, I get 70, I get 85, okay? So, c squared is in fact less than a squared plus b squared, so this is an acute triangle. Because c squared is less than a squared plus b squared, okay? That's how you determine, that's how you use the converse of the Pythagorean theorem. So let's look at C. And I'm going to throw in some radical math for you here. Let's look at C. How do we know what the two smallest sides are? Well, first of all, we need to determine if these are in fact triangles. So the square root of 10, if you put the square root of 10 in your calculator, you're going to get 3 point something. It's going to be larger than 3. And I'm going to show you how to use, so you get 3.16. So this is about 3.16. So keep that in mind. Don't use it. But we need that to know that 1 and 3 are our two smallest sides. So I'm going to compare 1 plus 3 to 3.16. And is 1 plus 3 greater than 3.16? Yes, it is. I can make a triangle out of this because 4 is larger than 3.16. So now I'm going to move on to the classification. And again, the classification is we're going to compare c squared to a squared plus b squared. The biggest side is c. Now, I'm not going to use 3.16. I'm going to plug this in. We're going to start learning some radical rules. So I'm going to compare c squared to a squared plus b squared. Okay? I'm going to check and see if these compare. What is square root of 10 squared? Well, square root of 10 times square root of 10, if you look at it this way, it's the square root of 10 times the square root of 10. And what does that equal to? The square root of 10 times 10, which is the square root of 100, which is just what? 10. Whenever you square something that's already a square root, it becomes that number. So square root of 10 squared is just 10. 1 squared is 1. 3 squared is 9, and 1 plus 9 is 10. So what do we have here? Whoops, let me undo that one. Let me take this guy out. 10 is equal to 10. This is actually a right triangle because c squared equals a squared plus b squared. So let's look at the last one. What are my two small? Square root of 9 and square root of 16. And we can actually reduce these. What is square root of 9? It's 3, or simplify, sorry. Square root of 16 is 4. And then we have the square root of 27, which is going to be 5.1, 5.2, something like that. So these are your two smallest. So the question is, first of all, is it a triangle? Is 3 plus 4 larger than 5.1? And the answer is yes. This is a triangle. So let's check it out and see what kind of triangle it is. Well, I'm going to take my c, which is square root of 27, and I'm going to check c squared and compare it, and compare it to a squared. We're just going to write 3 squared, plus 4, which is b squared. And again, I'm using 3 and 4 instead of square root of 9 and square root of 16. If you want to stick square root of 9 and square root of 16 in there, you're more than welcome to. And I'm going to put my little green circle because I don't know how these are going to compare yet. Square root of 27 times square root of 27, again, just like we showed over on the other side, that's just 27. 3 squared is 9, 4 squared is 16. 27 comes down, and that's 25. So now what I have is that actually c squared is larger than a squared plus b squared, so this is actually an obtuse triangle because c squared is larger than a squared plus b squared. And this is how you use the converse of the Pythagorean theorem. Now I'm going to show you a few more examples to kind of make things a little bit easier. I'm going to open up another document, and I'm going to open up a blank document here, and let's make this a colorful one. And I'm going to zoom in. So let me give you some numbers, and let's determine what kind of triangles they are. Okay, number 1, 7, 9, 10. Well, first of all, is this a triangle? Well, 7 plus 9 is greater than 10, so it is a triangle. So let's figure out what kind of triangle it is. And again, our mark is we are going to always compare c squared to a squared plus b squared to figure out what kind of triangle it is. In this case, I've got 7 squared. These are my two babies. And my c squared is going to be 10. So I'm going to compare 10 squared to 7 squared plus 9 squared. 10 squared is 100. 7 squared is 49. 9 squared is 81. And again, I've got my little green circles here. I'm going to compare these. I have that circle open because I don't know what it's going to look like. C squared is 100. And over here, I have 130. So what do you notice? C squared is smaller than a squared plus b squared. That means this is an acute triangle. C squared is smaller than a squared plus b squared. Okay, so let's do another example. Let's do example 2, and let's try this one. 6, 10, and 8. Well, once again, I'm going to take c squared, and sometimes my board freezes on me. I'm going to take c squared, and I'm going to compare it to a squared plus b squared and see what it's going to look like. Well, let me select my c squared. Well, what's my largest side? 10. So 10 is going to be my c squared again, and my a squared plus b squared are going to be 6 and 8. So I'm going to compare c squared to a squared plus b squared. I'll put my little circle there. I don't know what's happening. I don't know what it's going to look like. I got 100 over here. 6 squared is 36. 8 squared is 64. I'm going to bring down that 100. Bring down my circle because I don't know how they're going to compare. And 36 plus 64 is 100. So what happened? Well, what's happening is c squared equals a squared plus b squared. So this is an actual right triangle because c squared equals a squared plus b squared. All right, let's try one more. Let's do number 3 over here. And let's see here. Let me get some creative. Let me get creative here. I'm trying to think of something that would... let's see here. I'm trying to think of a number that would work. 6, we're going to use 6, 5, and 2. Again, and I'm making sure right now I'm picking all sets of numbers that make triangles. Remember, you have to make sure it makes a triangle first. And let me clean this up just to make sure, so you know that I always go back and fill these in. All right, so once again, we're going to compare c squared to a squared plus b squared. And again, this is the converse of the Pythagorean theorem. So what is my c squared? Well, my largest side is 6. So I'm going to have 6 squared, and I'm going to put my circle here, and I'm going to be comparing it to 5 squared plus 2 squared. So 6 squared is 36. 5 squared is 25. 2 squared is 4. And so I'm going to bring my 36 down. 25 plus 4 is 29. So I have that my c squared is actually larger than a squared plus b squared. So this is an obtuse triangle. This is using the converse of the Pythagorean theorem to determine what kind of a triangle you have. And this is a way that you can use c squared and compare it to a squared plus b squared to determine acute, right, or obtuse. And once again, it has to make a triangle first.